Hello, everyone, and welcome to a new episode of The Rambling Loop. Good to see you all, folks, here. Thanks for joining us. We are live on Twitch every Wednesday talking about the cool parts of AWS networking and content delivery. I mean, the cool parts, all the good parts, all the parts, not
All the
just the
parts are
cool.
cool, so that's the cool parts.
Exactly.
That counts for
Exactly.
everything.
Exactly. I'm Alex. For those of you who don't know me, I'm a networking specialist solutions architect within AWS Networking Services team. And I've been a host on this show for many years now already. I don't even know how many years. And I'm joined today by Matt and Mohawk. Do you folks want to introduce yourselves? I think, Matt, you don't need intros, but everyone knows you. Go ahead, though.
Mohawk, tell us about yourself.
I'm an engineer on VPC Lattice side. Been on this journey of fun development for about 4 years now.
Very nice. Very nice.
What's it like being an engineer on the VPC Lattice side? Like, what does your day look like? Are you mostly writing code, or like testing different pipelines, or operational readiness around different code deployments? Like, what do you actually do? I'm super curious.
As part of my role, I've been doing multiple things. I've been involved in customer meetings. I have been doing designs for the new features, kind of trying to understand what customers are also asking for, reading kind of in between the lines as well, and figure out a way how we as a team can deliver something more delightful for our customers.
I think that sounds like it's a great opportunity for folks on the chat. You're talking to one of the few people who builds the actual AWS services that you use. So if there's any feedback, pop it in the chat, and it'll be heard by the folks who are actually coding and designing and thinking about this stuff. So that's awesome.
And Dominic here, a longstanding follower of our show. Thank you, Dominic, for joining us today. He's like gathering feedback from Alex. Yeah, Mohawk and I talk a lot. Like, I think he already hates me. He's tired of all the things that I bring to him. But yes, we do talk a lot. So I was thinking that he would be the best person to talk about what we have in store for you folks today. I want to make sure everyone's aligned on what we're going to be talking about today, which is the new Amazon VPC Lattice support for custom DNS for resources. Now, I know that's a long title, it's a long name, it's a long feature name altogether, but I promise it's really interesting. And the other cool part about the show today is that Alex here is going to try to do a demo of a feature she has not tested before. So hopefully the goal is going to be to show you how easy it is to do it, even if you've never done it before. So yeah, should be fun. Hopefully, I'm really praying to the gods of demo and the universe that everything works. But I do have Mohawk here to guide me, and I have Matt to help us with all the good questions from all of you folks. So please do put your questions in the chat, and let us know where you're joining us from. I see here we have Jaspreet Work 65 joining us from Canada. Mohawk, you're in Canada, right?
Yep,
Where are you
beautiful
based?
British Columbia. I'm from
Nice.
Vancouver.
So cool. Okay, so this
Is
is
it
great.
getting cold up there right now? As I know San Francisco I'm in San Francisco. It just turned cold yesterday or today. Hopefully the warmth come back, but
Yeah, for us, it's like rain, 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 then snow, and then it goes to rain again, and then summer hits.
Well, given that we're talking about cold weather, before we dive right into the topic for today, I wanted to show you folks that I have already all my Christmas decorations on. So I'm looking forward to Christmas this year. I started 2 months early, but no issues with that. Let us know in the chat if you already have your Christmas decorations on. I have had them on since 1st of November, by the way. Don't judge.
so
Thank you.
I did actually find what Alex's mug reminded me of, and it's a children's book that I've been reading my daughter called Mrs. Wishy-Washy's Farm. You see the artwork is very, very reminiscent.
Perfect.
But it's like a really cool kind of fall vibe. Yeah, awesome.
Yeah, pretty cool. Pretty cool. I see already folks starting with questions. So I think we have to dive right in. But before we talk about custom DNS, I think just to make sure everyone knows what VPC Lattice is, we were laughing a few minutes ago about the fact that we do need to say, like, at least give 2 sentences on what Lattice is for those of you who are not familiar with it. Mohawk, do you wanna give us that quick intro into VPC Lattice?
VPC Lattice is, in general, a cool service that allows you to not worry about networking, how the applications connect with each other, and build cool applications as a developer. Focus on that. Be able to allow you to have like multiple things in one place, I guess, one-stop shop, where you can have connectivity for yourself. You can have applications, anything that you need in your day-to-day application or deployment as well, like blue-green deployments. You need security. You have like auth within VPC Lattice. You need observability. You have logs and metrics in there as well. So I sum it all as like one-stop shop for developers to build their applications.
That's awesome. Okay, I feel like there's a key word there that you mentioned, which is a one-stop shop for developers. I think from a VPC Lattice perspective, we've talked about it so many times as being a networking service. However, if we take a step back, traditional networking means essentially just routing things or just giving or creating reachability between VPCs and between transit gateways and using Cloud WAN and all of that. I think there is the very important distinction around traditional networking and VPC Lattice, which is the representative service for application networking on AWS, which is actually the fact that Lattice allows developers to connect their applications together without having to worry about traditional networking constructs, right? So you as a developer, you wouldn't need to create routes and route tables and make sure you have BGP configured and all that stuff. You just need to say, hey, this app needs to talk to this app or to this database, and it needs to happen securely, and I need to have monitoring around it. And by the way, this app needs to also transition to a new version. So I need to do some blue-green deployments, or I need to move this app from EC2 to EKS, Elastic Kubernetes Service, or ECS, Elastic Container Service. So containerize it, modernize it. That's where you get all of these things in VPC Lattice. It's not traditional networking, it's application networking. Now that we've cleared that. No BGP, no BGP. No BGP, no. I think there was a joke a couple of years ago about the bridge gap protocol. No BGP in any way, shape, or form, however you may translate that acronym. Nothing around that. Just intent-based connectivity for applications, services, resources, and that's about it. I do want to call out a couple of things, though. We talk about resources today, and we're going to talk about resources. I think it's important for everyone to know that Lattice supports two kinds of things, these things that developers build and that need to talk to each other. It's services and resources, right? Mohan, do you want to tell us what the difference is between the two?
So generally, as a developer, when I look at services, I see it more like a traditional request response, HTTP, HTTPS applications. You can sneak in here anything that you have like a layer 7 attributes attached to the connection or request, versus the resources, which will be your traditional like a source to a destination connectivity at an L4 layer. You do not necessarily have information about layer 7 stuff, like, for example, your databases. That's where I would say like resources fits more than the services.
Cool. Okay, so we have services, we have resources, and Lattice brings them all together into what we call a service network, which is just a logical boundary that says these services and these resources and these clients should all just talk to each other. I think it's about the time we do a bit of drawing. What do you guys think? Should we?
Yes, we should absolutely do some drawing.
Let's do some drawing. I'm the designated drawer here today.
Well, when we're using native iPad to screen sharing directly from Alex, so I feel like our drawings are going to be quite neat and amazing today versus Jamie and I's usual chicken scratch. But let's do it.
Well, let's see if I rise to the expectations. So we said that actually, let's start with one important thing. We have in AWS the concept of accounts, right? So we may have a multi-account deployment. Let's say this is account 1 and this is account 2. Accounts are your billing boundary, your resource level boundary, your security boundaries. Like when you get started with AWS, you have an account for sure. And then you grow, right? And you get to the place where you have more than just one account. And you're developing and deploying your applications and your resources across multiple accounts. And in these accounts, might I say, you have multiple VPCs, unless you go look at the episode we had 2 weeks ago about shared VPCs. Shared VPCs work as well. You could have shared VPCs for sure. Let's say this is VPC 1 and VPC 2 and VPC 3. And I think I'm losing all developers at this point because everyone's like, wait, you said you're going to talk about applications. For sure, that's what I'm getting at. But VPC is your foundational deployment private network where you actually put these applications in, right? So here's where you're going to have your EC2 instances and your Kubernetes clusters and all the compute for your applications. So let's say that I have some apps here. Let's say app 1 is maybe an EC2 auto scaling group. If folks are familiar with that, probably main EC2 instance automatically scaling. Let's say that I also have app 2 here, which is maybe an EKS service. And let's say I have app 3 here, which is a Lambda function. You don't necessarily need to deploy the Lambda function in VPC. You can also deploy it outside of the VPC if you want to. That's essentially, I think, the default deployment model. And let's also create here maybe app 4. What compute did I miss, folks? I think I missed this ECS, right? Let's say ECS task. And last but not least, let's create a database. Let's say database 1. And let's say this is Aurora. Seems like a reasonable.
I think we've got a pretty good application deployment here, a group of applications that are serving something as a system.
Cool. Okay. Let's say that, Moha, give us an example of what these applications could do, because we're both networking people, so we have no idea what apps do usually.
How about we take an example of, let's say, a parking service that you have to connect with each other, like for payments, for parking, for calculating rates.
Oh, cool. So this is payments, and this is maybe rates, and this is the database that has in it what? Mappings of whatever.
Yeah, like storing the user information, like parking lots, all that stuff.
Parking, okay, and
you could have like license plates and entry time and exit time and unique ticket identifier.
Cool. So I have also the CKS service that's tracking, and then maybe I have what else? One more. So I have payments, rates, tracking, the database, and
billing.
One more. Billing. Perfect. Billing. I love it. Okay. Make billing an ECS task. I don't even know if that's.
So I think you're going there, but this leads to the question of what happens if rates needs to talk to billing.
Exactly. That's what I'm getting.
Actually, it would be the other way around, right? It would be billing to say, we need to bill a customer. What are the current rates? We need to go and get the current rates from our rates service.
Exactly.
How do we do that?
Exactly. So let's say that, hey, app 4 needs to talk to app 3, right? So billing needs to talk to rates. And then let's say that payments So app 1 needs to talk to, I don't know, rates. App 3. Bear with me, folks. I'm not a developer, so I have no idea how apps are built.
I think this
Just
is
saying.
we're building an app right now in my mind. But
Yeah.
again, I'm from the
Yeah, we're
networking
building an
space
app.
too.
That's pretty
So.
cool. That's actually pretty cool. And let's say that who needs to talk to the database? I think billing needs to talk to the database for sure, because like that's also why they're together in that same VPC. But maybe
I think
rates needs to talk.
rates.
Yeah.
Yeah.
So let's say app 3, which is rates, needs to talk to the database. Cool. So we kind of have our flows here, right? So I have this one needing to talk to this one. App 4 needs to talk to app 3, and app 1 needs to talk to app 3 as well, right? Pretty cool. I bet interactions are probably much more complex than that. But at this point, we kind of want to put something in here. What would be the first thing that everyone would think about to do? Well, I tell you, which is something that I see developers across the board do, peer these VPCs together, right? However, if you start with the default VPC, for example, in the AWS account, raise your hands, everyone who's following us today and uses the default VPC, you're probably going to have a 172.16.0.0/12 in every single account, overlapping IP space. So pretty interesting. Also, not necessarily mapping to your intent, right? Your intent as a developer is expressed in, hey, this thing needs to talk to this thing, right? Not necessarily I have these VPCs that I need to peer together, right? So stepping up from like layer 3 connectivity, right? That's where VPC Lattice comes into play. So I'm gonna copy this just to make sure we're not making a mess out of it and can reuse it later, right?
So let me just step back for a second. As a application developer person, I've been maybe vended a VPC for my application. So hey, I go to ServiceNow or something and say, give me a VPC, or give me an environment I can deploy my application. And you're given this thing that's a VPC. You use a service of choice, EC2, EKS, ECS, your own role, your own whatever it may be. You deploy your application. You're now in this environment. How would you then, I mean, I think you're then going to maybe ServiceNow or something else to say, I need to connect to another application. And someone somewhere is making a call to say, let's connect those two together. Or maybe if you own the environment, maybe there's a person that is the infrastructure engineer and they say, let's use peering. And so what's the reason why they didn't use peering? There was overlapping IPs.
Well, peering is really good if you don't have overlapping IPs, and also you're not operating at scale. So let's say if you're maybe just getting started with AWS and you're like, oh, I have just 2 VPCs in 2 accounts, let me just pair them together. Pretty good. But take that and scale it and say you're going to end up having 100 VPCs or 200 VPCs or thousands of accounts. Peering is not the best option. Also, peering gives you full layer 3 connectivity, right? So it's essentially like putting all of these things together in the same VPC, logically speaking. So pretty hard to put security in there, right? You have to configure security groups. You have to make sure you're tracking what can talk to what. It's not an on-point thing that says, hey, app 4 needs to talk to app 3. Or app 1 needs to talk to app 3. I'm not saying everyone can talk to everyone, right? Which is what peering gives you by default. So a couple of considerations there around scale and around what your actual intent is. Also, to do peering, you have to do route tables. So you have to kind of understand, go back to those roots of understanding IP addresses.
So then, Alex, are you saying as a developer, I don't need to worry about overlapping IPs or having to manage these subnet CIDRs, like carefully managing or planning for it?
Exactly. So if I put this one in here, I'm going to actually intentionally do this. And 172.16.0.0/12, and I may have 172.16.00/16. Sorry, not /12, but /16. Yep, all of these VPCs can have the same IP space. If you have this set up, you can't peer them. You can't put transit gateways in there. You just need to put some NAT capabilities, and you need to think about IP addresses. With Lattice, you don't. So let's see what Lattice brings to the table and how this works, shall we? So
I'm holding back from talking about transit gateway and how that solves the VPC to VPC sprawl, 5,000 VPCs interconnected. I'm also holding back on, is it a good idea to have overlapping IPs? Maybe not, but maybe you're forced into that for various different reasons, like lack of RFC 1918 addresses. What I do like what we're doing here is we're basically seeing around corners to say,
Yeah.
these are probably the issues that you will run into as your environment scales. And so whilst right now with two accounts, 3 VPCs, it just feels like peering or transit gateway is a much simpler and better and easier solution. I think the real answer is, in the future, you can paint yourself into a corner by using overlapping IPs, or by using transit gateway and having VPC sprawl, or by only relying on peering and routing to interconnect applications. So I think we're working in the future here on behalf of customers. I like it.
Exactly. That's part number one. And part number two is, if you get to try that peering, or if we get to saying you should do non-overlapping IP space, right? Because that's the good way to do it from a networking perspective. We're again painting developers into a corner where they need to understand, wait, so how do I assign non-overlapping IPs? Like, how big these IPs should be? How big should these VPCs be? Should I just give them 1/16? Like, how many IPs are in a /16? Like, how do I think about that? How do I think about how big my subnets should be? How do I go interact with my networking team to say, hey, I need these 2 VPCs with this /16 here and this /19 here, and like these 4 subnets in here. It's a lot of cognitive load that developers shouldn't need to have, right? They literally, all they want to do is this, right? Like, they shouldn't have to care about anything else. So
I wonder, just a quick comment. We always have a lot of folks that want to attend 100 level networking. And I'm sure there's a bunch of developers in there that are stuck in this same situation where they are being told they need to assign a CIDR, and they're thinking, what's a CIDR? So maybe we'll have less attendance on 100 level sessions now because we've said, hey, don't worry about it. We can use VPC Lattice. Well, let's get there anyway. I keep interjecting.
That's good though.
But
it is
just one more thing here. Like, as we talked early on, Lattice being a one-stop shop, there's one key thing missing here as well. As developers connect these VPCs, or they have other mechanisms to connect each other, there's still something fronting these apps as well, like be it an ALB, NLB, or something else, like even if their own Route 53 custom DNSs that sticks in those ECS task or EC2 IPs behind those DNSs to send traffic over. This is where Lattice also kind of removes those layers as well.
Yeah, so let me put this out here. So let's say that if we zoom in, this is my zoom in drawing, by the way.
Great.
In app 1 here, which is the EC2 auto scaling group, right? This is probably an application load balancer with a listener on port maybe 443 with a target group. And this target group is your auto scaling group, correct? So you might have here, this is the ASG, and you've created the ASG and you've integrated with a load balancer and you're configuring all the stuff there, right? Like, kind of this is what hides behind app 1 in a classical world. Let's see what you don't need to do with Lattice. And let's start from developers. Again, very straightforward, very simple. Let's say this app, now app 1, becomes what we've talked about as a VPC Lattice service, right? So let's do the icon here for VPC Lattice service. Let's call it payments. We do this a bit bigger, right? Now this Lattice service actually has listener on port 443, and it has a target group, which is the auto scaling group, and it has a name, payments, right? Like all the stuff that you were used to defining on your application load balancer or that developers need on their application load balancer now are available in Lattice too. So you don't need that application load balancer. So essentially that target group of this service is going to be what? This auto scaling group, right? That's the target group of that service in VPC Lattice. Still relies on your compute. So whatever you choose as the compute, this is your target group. And we were talking a bit earlier about doing blue-green deployments and migrations from a certain compute type to another compute type. You can always add another target group, and you can say, wait away from EC2 auto scaling group, and let's move this payments to an EKS-based deployment, right? Because we're modernizing it and we're containerizing it. So you can do that as well. Now, what else do I need to do? Well, every single one of these folks is going to be a Lattice service. Tracking. Again, backed by whatever compute is here. And Lattice has native integration with EKS, with auto scaling groups, with ECS, with Lambda functions. So all the compute types that you can use or compute options you can use on AWS are natively integrated. So let's say that this is listener port 443. I'm assuming everything is secure here, by the way. 443 encrypted TLS, please. Don't use port 80. Target group is my EKS HTTP, EKS service. And name is tracking. And by the way, for all the secure parts, so for TLS and for the certificates, Lattice integrates with AWS Certificate Manager. So you don't have to manage your certificates on your hosts or in another place. You just put them in ACM and configure them on these services. So while I'm creating these apps here, these services for every single app, again, what was the difference between a service and a resource?
I don't know. You tell me.
Mohawk, what was the difference?
Services will be targeted towards more applications which are like layer 7, HTTP, HTTPS sort of use cases, gRPC, like, whereas the resources will be more layer 4 connectivity to the thing, I would call it things that doesn't necessarily have the layer 7 attributes attached to it, like databases.
Perfect. So
Like you just passed the final question on the exam. I think.
Excellent. I see folks in the chat are already talking through the custom DNS part. We're getting there.
I think we're ready. We're ready to talk about custom DNS.
Exactly where we're getting at. So to create resources, you need a couple of things. So you first need a resource gateway. This is a construct here that you deploy in the VPC to give Lattice a presence in the TCP world, right? So in the place where it has layer 3 connectivity to your various resources. And you need to create a resource configuration. And this resource configuration points, oh, my diagram here, this resource configuration points to whatever you have as a resource. It has ARN integration with databases in RDS, so RDS or anything under RDS. But let's also say you have maybe an EC2 instance here. This is like a 3D EC2 instance. Let's say I have an EC2 instance that has a TCP app here, right? Not HTTP, not HTTPS, not layer 7 stuff. Let's say we have a TCP app on port, I don't know, 3289. I hope this is not a port that's used for something else. What do I do then? Well, I create a resource config, and I can point this resource configuration at the EC2 instance, at the TCP app, even using either IP or DNS name, right? So let's say that this TCP app has the name my TCP app.example.com, right? I'm pointing the resource config to it. Okay. Does it make sense so far? I've created the services and I've created the resources, but I'm missing something. What am I missing?
Where's the clients?
Correct. So things need to talk to each other. Services need to access other services. Clients or services become clients when they're accessing other services, and they need to have a means to do that, right? So if they need to do that, we need that third construct that Lattice brings in, which is a service network.
I was wondering how you were going to draw that because we didn't have any room in between the VPCs, but you've impressed
Pretty
me
good,
again.
right?
There you go. I was waiting for you to shrink everything down to make room for the service network in between all the VPCs.
Yes.
And I would almost draw that like a transit gateway between VPCs, but really it's a different construct that I guess you can draw to the side, right? That's giving you
I
that
could also
connectivity.
draw it like this. Actually, I think this one would make even more sense because the service network here is a construct that can be shared across accounts. So again,
We have a question here from Tech First. Can you
yeah,
also explain in this diagram what we had to use for DNS and where before
100%.
this custom DNS feature, or
Yes,
what it was like
exactly.
before the feature?
That's where I'm getting at. Exactly where I'm getting at. So now this service network, we said it's a logical construct that brings together clients and services that need to talk to each other in the same common boundary so that they're able to talk to each other, right? So coming back to our intent a bit higher here, we said these things need to talk to each other. So this is our intent. Now, this intent gets translated into what we put into the service network, what we associate with the service network. So let's say that this VPC needs to be associated with the service network. Actually, let me make this a bit thicker.
I think just for clarity, Black Box Beats asking, are we talking about network? And so essentially there is a network that AWS manages under the hood for interconnectivity. But I guess, Alex, you want to talk about how this is an abstract away from that?
Yes. So when we talk about network in general, like if we are to say, oh, what is a network? If you ask a network engineer, they're going to say, well, it's a collection of layer 3 routes in a route table, right? And so paths in a route table and things that can talk to each other using IP addresses, correct? It's kind of, I think, what a definition of a
That
network
sounds like
is.
a good definition to me. Yeah.
Cool. The service network here, though, is a network, but it's not the traditional network. What was the definition we gave for the service network? It's a collection of things that need to talk to each other, right? A collection of clients that need to talk to services and resources, right? So we're taking the concept of traditional networks, which are a collection of layer 3 things that can talk to each other using IP addresses, and we're putting it a layer higher, where this network is now no longer a collection of IP addresses that can talk to each other. It's a collection of entities that can talk to each other, right? And they don't care about IP addresses, right? They just care about being in this service network, and they care about the configuration being accurate, right? That's all. There's no IP addresses, there's no routing. App 4 here, to be able to talk to app 3, needs to be in a VPC that's associated to the service network. And app 3, which is the one that is being called, needs to be associated with the service network, right?
I think what's interesting
essentially,
here is it this abstraction of physical networking into the logical world. We've been doing it for a long time. When you've got an EC2 instance and you've got an elastic network interface, it looks like a network interface. It feels like a network interface, but
yeah,
really it's just essentially a database pointer. And you don't realize
exactly.
that because it's exposed like a traditional network concept. And I think my take on this and the way you're describing it is we've basically just taken that one step further. We've said, well, hold on a
Exactly.
second. We've tried to give customers IP addresses with elastic network interfaces, but do we really need that? Not really. Let's just
Exactly.
have that fabric of connectivity and define the connectivity in different terms so customers can use it in an easier way, rather than learning
Exactly.
this new language, right? Or AKA CIDR addresses, subnets, routing, BGP, all that kind of stuff, right?
Yeah, exactly. Um, exactly. So we've translated layer 3 IP connectivity, as in this IP can talk to this other IP, into an abstracted concept that says app 4 can talk to app 3, right? Like, that's all. Like, there's no
That's all.
IPs, there's
That's
no
all it
routes.
is. It's all already.
Yeah,
There's an
exactly.
identifier and a flow, right? And so super simple.
Exactly.
So how do we tie custom DNS into this?
Okay, so we've attached here these services. You see these arrows? These are services that are attached to the service networks. And then we've attached VPCs to the service networks. And now, in traditional layer 3 world, you said, oh, I'm going to ping 8.8.8.8, right? So I'm going to ping that IP. However, in application world, you're not pinging anything. You're not pinging IPs either, right? You would most likely, or this app 3 needs to talk, app 4 needs to talk to app 3, would probably translate into app 4, some process, right? Whatever, doing a call, maybe like think like a curl, right? Curl HTTPS : slash I don't know, app3.example.com. Actually, we gave a name to app3. We called it rates, right? So let's say rates.example.com, right? On whatever, slash latest, right? Or something. That's the developer speak, right? By the way, I'm talking, not a developer, but I've become friends with curl quite a lot. So let's say you want to do a curl. This is essentially accessing app 4, right? Or app 3. It's trying to open a connection to that, trying to do something, a business logic, get the latest rates, right? So here's where the magical DNS comes into play, right? Every single one of these apps needs to have DNS configured. Let's take the example of our resource here, which is called mytcpapp.example.com. If this needs to be accessed by clients, they're going to be using mytcpapp.example.com, right? Like, they're not going to remember IP addresses. They're not going to be thinking about routes and all of that, right? They need the domain name, and they need to be able to resolve that domain name to something, doesn't matter what gets them from where they are to where this application is. So let's say, for the sake of the example, that app 2 here, this app 2, let me do this, so, wants to access this instance, right? what would app 2 say? Let's take the flow and break it down. App 2 on EKS wants to access my TCP app, which is on EC2, right? The first thing that happens is a DNS query that says who is my TCP app. Now, DNS queries usually resolve to IP addresses in the layer 3 world that you have routes in your route tables for, right? Here, there's no routes, there's no route tables, there's no layer 3 information, but you still need those IP addresses. So here's where the custom DNS piece comes into play. As a resource owner here, as the owner of the TCP app, right? When I define this resource config here, I say custom DNS is my TCP app.example.com. So far, so good. Step number 1, I define the resource config and I give it a custom DNS. Step number 2, as a client here, when I attach myself to the service network, this is called service network association or service network endpoint, works both ways. We can look at it and dive a bit deeper as we go through the console.
Yeah,
I
Alex,
will
just a,
say
just a
here.
side comment here, and it's a bit of chat here with Ken and TechField D about, are there any good like VPC Lattice labs? I think we've got Skill
We have
Builder.
a bunch of stuff in GitHub that you can go and download and build your test deployment for sure.
Yeah, there are a few EKS workshops as well.
Yep. So just to finish this one, because I really want to get into the console to do that demo. When you create this association here or the endpoint to the service network, you're going to say custom DNS enabled, which means that all of a sudden, this app 2, when it tries to resolve the DNS name, right, we're saying here, it's going to get back a VPC Lattice IP that is going to allow it to actually create packets, right, that request that goes to the service network, that goes through to the resource config, that then goes to my TCP app, which is right here, right? So essentially, this is what custom DNS name does. Allows you to sort of put it on AWS and let AWS manage the DNS configuration for your VPC, for the client VPC, so that clients in that VPC can automatically resolve DNS names of your TCP resources in VPC Lattice to whatever IP addresses they need to get to that resource configuration in Lattice, right? Pretty straightforward, I think, right? Any questions? Should we jump into the console?
Let's jump into the console. And there was a question from TechFueled. It's just a little far back here. So today we created a PHP for Lattice generated service. Am I right in assuming this feature allows us to extend the Amazon AWS.com DNS namespace?
Yes, 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 yes. Perfect. Let's do that. Let's actually do that because I'm really excited about it. Let me share my screen here. Let's see. Okay. Can you folks see my screen? Should
We
be
can.
good.
Yep.
Is it big enough for everyone?
It is for me, and I've got a pretty small screen, so I think we're good.
Okay, perfect. Cool. I have some VPCs here. I have a test custom DNS names resources VPC, and I have an EC2 instance in it. And I'm going to create actually exactly what you mentioned. What was the example with EFS? Maybe I think was EFS.
I think it was. I'll find it here again. Yeah, it was here.
Okay, so let's do EFS. What you're saying is, let's say you have in your my EFS endpoint. I'm gonna search EFS here. This is a private link endpoint, right? I'm gonna just do the normal EFS endpoint, right? I'm gonna create it here in my test, custom DNS name for resources. I'm gonna say enable private DNS name, etc., etc. I'll just select the subnet, so private in every subnet. Okay, perfect, perfect, perfect. I'll just give it the default security groups and just create the endpoint, right? Created the endpoint. Now, I want this endpoint to be used by other clients in other VPCs as well, right? This is the analogous of my TCP app, right? I also have a real TCP app, so we're going to do that as well. I mentioned I have an EC2 instance. Now, what did I say I need for resources? First thing, a resource gateway. The resource gateway needs to be in the VPC that contains the resource, right? I already have the resource gateway here. It's called test custom DNS names resource gateway. Perfect. I shouldn't have any resource config. I actually have a resource config here. It's my TCP app. I'm just going to delete it, actually, just to create it again. Oh, no error has occurred. This works. Okay. So I have a resource gateway. And for this resource gateway, I want to create two resources. First, it's going to be my TCP app. And second is going to be that private link endpoint for EFS. Let's do this. I'm going to be fast. My TCP app. For those of you who are not familiar with resources, by the way, I think we have a demo on the routing loop in past episodes about how to create resources. So you guys should check that out.
I'll find the link and post it in the chat.
Perfect. Okay, so I have a config type resource, single, just keeping things very simple. And I have the setting here, custom DNS name. Use custom domain name. I can provide a name here. What did I say my name was? My TCP app. Oh, this looks so bad without dashes. .app.example.com. And you can also have it verified. Verification is especially important for SaaS providers and ISVs that want to have their DNS names used by their clients, but you don't necessarily need this. This is optional. So I don't have to own example.com. Everything is private within my my environment. So I can use whatever domain I want for this. And I'm going to do an IP resource. And I think the IP address for my resource here is, we'll find it in a second. I'll find my instance IP address, because I'm going to just do by IP. And 10.0.10.90. For the port ranges, I'll just leave it default, 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 create resource config. And then the other one is the resource config I want to create for the private link endpoint, right? So let's go back to endpoints. Let's see what the EFS endpoint is, the DNS name, right? I've copied it from here. And I'm going to go into resource configurations, create resource configuration, EFS endpoint, TCP, all good. Custom domain name, it's actually going to be, let me paste it here. Right? Elastic file system.usestorm.amazon.aws.com without VPCE. Actually, let's make sure we don't do open link in new tab. We don't do something messed up here. I'm going to double check the DNS name. for the CFS endpoint. Yes, this is it. I'm just going to paste it here. So Elastic File System, UC Swan, Amazon AWS.com. Perfect. We're good. Okay. No verification ID. I don't own this domain name, so I'm not going to verify it. DNS resource. The DNS name is actually the VPC endpoint name, right? So I'm just going to paste all of this here. And that's about it. Oh, what did I say? Oh, I did not select the resource gateway. Now I selected it. All good. Okay, perfect. Now I have two resource configurations, my TCP app and the EFS endpoint. They both have custom DNS on them, right? So let's click on one of them. See this domain name here? That's the custom DNS. This domain name, that's the custom DNS, right? Now what do I have to do? Associated with the service network, right? So I'm going to go to my service networks here. I already have a service network that has a bunch of things in it. By the way, here are all the cool names that EKS uses for their clusters. This is amazing. I love these names. Okay, so I'm going to create an association. Oh, what did I do here? EFS endpoint and my TCP app. You see private DNS name enabled. So the service network owner can also configure this if it's allowed or if it's not allowed. And now this is great. I have my resource associations here on the service network. I can do a refresh here. They became active. And now let's go on the client side. On the client side, I don't have any VPCs associated right now. So I'm going to create a VPC association. And my VPC is going to be the control plane VPC here. I'll put some security groups by default. And this is the cool enable DNS names. And here's where you get, as a VPC, client VPC, you're going to say, do I want to allow all domains? Do I want to specify the domains that I want for Lattice to create and manage DNS for me? Do I want verified domains only? Or do I want verified and specified domains? By the way, Mohawk, I'm really excited about these options. I know we've talked about them. This is amazing. I love it. I am super, super happy. I'm just going to do allow all domains here. Just keep in mind that if you don't verify your domains and you allow everything, you may bump into challenges with your developers picking up random names. But I'll trust my developers for now. So I have the VPC association. Once this is done, I'll go on the client side and I'll show you folks how that works or what it means.
So
And
why?
by the way,
I was timing you here, and that took 6 minutes. It's pretty good.
6 minutes with all the explanations, by the way, because if I would have done it a bit faster, it could have been like 30 seconds.
Mohak, you were going to say something.
Yeah, Alex mentioned about like, hey, I'm going to trust my developers and so that they don't randomly accept any domains. There was one cool stuff that Alex showed previously where you can enable private, as a network admin or a service network admin, I can control before it goes into the hand of my developers, like the clients, which domains I'm going to allow for them to access in the first place.
Yes, exactly. So when you associate resource configs to the service network, you can set this resource config should have its domain name automatically populated. This other resource config shouldn't. So you own your destiny first and foremost. And then you can let client VPCs also control these things. So you have controls in all places depending on how your organization is structured. While this VPC association gets created, I did notice TechFueled, Tech First's comment. There are a lot of associations in VPC Lattice. Everything is associations because that's the intent. I think that's so important. Associations are the translation of your intent. So that's it. You
But
want things? Yeah, go ahead.
This is interesting, Alex. There's a lot of associations in Lattice, but do I need to know as a developer or as a service or resource owner, do I need to know about all the associations or all the
No.
constructs?
I would say no. I would say that you only need to know about your stuff being associated. That's it. And you don't actually, I think, if I think about it even more, I don't think you'd even need to know about the association. I think the only thing you need to know is that this is my resource or this is my service, and hey, these folks need to access it. That's it.
So as a developer, I just need to know I need to create a resource, like one-click resource creation or one-click
Exactly.
service creation, not necessarily I need to create a service network, a VPC
Exactly.
association or anything. Okay.
Yep. Let's test this out because we only have 4 minutes, and I'm really curious if I made it right. So let's see. I'm gonna go
Let's do it in
here.
2.
This is my control plane instance. This is the instance in my control plane VPC. I'm going to connect to it here using EC2 instance connect. Share this tab instead. Okay, perfect. We're here. And how do we test this private DNS thing? Who knows the command? Really easy. Dig. We do a DNS lookup, right? That's all we need to do. My TCP app.example.com. This is the Lattice IP.
Looks pretty
right?
good to me.
Pretty cool. Pretty cool. Let's try EFS. I forgot what the EFS name is. Give me 1 second. Elastic Files System. That's the name. Okay. Dig. Elastic File System .us east 1 .amazon aws.com. That's a Lattice IP, right? So automatic DNS management for all your resources in the service network. The only thing the developer needs to know is what's the name of that thing that I need to access, and that's it. Nothing else. Do I care how this IP is routed, by the way? Nope, I don't. It's there. It's already taken care of by VPC Lattice. We can look just for the fun of it in route tables so that you folks can see that there's some Lattice routes in here, but there's literally not here. Let me see if I find some routes here. Not forestry. I don't even find those routes right now. Super important. You don't care, and you shouldn't. And that's what Lattice makes amazing. Like you just have it there.
Cool.
All right, we're on
Cool stuff.
time. Pretty amazing.
Time.
Put some links in the chat. Thanks everyone for joining.
Thank you, folks,
Great
for
job,
joining.
by the way, Alex.
Thank you. It worked.
And thanks for joining us, Mohit.
Cool. Thank you, folks.
Thank you, Mohawk. Thank you, Matt. Have a good one.